Good afternoon, this is Schweitzer, and we're going to do a little preliminary quiz for quiz 16 answers and move along relatively quickly here. Alright, so we have a piece of copper is dropped into 1 molar of silver nitrate, a dark substance immediately forms. Which the following is true regarding this process? Okay, so well, one's running, so we have copper metal plus Ag plus is running. Now, there's no charge here. 1 molar silver nitrate. So which of the following is regarding the process? The reaction will have a K value greater than 1. Alright, so since we don't, when we run this thing, we have copper plus 2 plus silver metal. Technically, to be guaranteeing a over greater than 1 value, you'd have to have 1 molar concentration of this and a 1 molar concentration of this. And since we don't have this, my reaction, reactant concentrations, product concentrations, when I run to products, I am right now, so I only have the reactant. I'm buried at the beginning. My Q is infinitesimally small. So I don't know where I know I'm positive right now, but I don't know if I would still be positive when I get to this scenario. In that case, that is a no. Delta G prime is negative. Again, we don't know that for sure. If this is positive, then delta G prime is negative. So I'm going to change this on your test eventually. So I'm going to change this off of here and just make it regular delta G. And that would be here. The delta G at this point would be equaling negative. So at this point, I'm going to take that off, and then I'm going to put a yes on this one. And then delta G is getting larger, and that is approaching 0. That is also a yes, giving me C as my answer. So if that isn't changed, then 3 is the only answer, and there's no option here. So that will be changed eventually. All right. Regarding the copper and silver reaction described above, or allows to run until the reaction appears to have stopped, which the following methods would be used to increase the voltage and then run again. So if it's stopped, my electric potential actually equals 0. And that's because my Q now equals my K. And my ratio of products and reactants is to an end point or equilibrium point. So I need to crank up my reactant concentrations to get this to work. Or reduce the product concentration to ramp the voltage back up and get it back to running again. But cut the copper metal into shavings. The solid has no concentration change, so that would be a no. Add 2 molar silver nitrate, so we're going to up the concentration of the reactant. That would be a yes. Warm the solution. Technically, that will change the value of K, so therefore Q would no longer equal K, and we'd be able to run again, so that would be yes. That's 2 and 3. All right. Down here, which of these, so we have an electrical potential occurring here. Bubbles appear to be at the leftmost electrode, and the solid appears to be the rightmost electrode. What is the right reaction taking place at the rightmost electrode? So we have a beaker, and we have 2 electrodes in here, and they're being run on a power source. All right, we have bubbles occurring on one side, and we have solid occurring on the other side. That solid, we're in the same reaction, would mean that is solid silver. And if you look closely, this is the only one that accurately shows that production. Next one. All right, 2 copper samples are being electrolytically reacted, and they're forming copper. So one has copper plus 2. This is A plus 2 converted over to copper metal, and that requires 2 electrons. Copper plus 1 going to copper metal only requires 1 electron, and this because we have the same number of electrons that we're putting in, because we have the same time and the same amperage, this requires twice as much electrons, so it will be B will be double A. This will be double this one, so it will be C. All right, next one. All right, we're looking to match this. And matching this means that this one and they're both reductions, so one of them has to get flipped. They both can't be flipped. But this is a reactant here, so that one's going to stay. This is a reaction here, it's a product here, so I'm going to flip this one. So 0.17 and a positive 0.50 gives me a positive 0.67 volts. Write a balanced equation, calculate E. Well, that's the E. That's the first question. Balance is going to be, in this case, to balance it, this side gets multiplied times, well, nothing. And this is going to multiply times 2. So 2 and 2 and 2. Alright, so this is just going to be a 2 here and a 2 here. And this is my balanced equation. Calculate K. Alright, now the next two questions, one's calculating K, one's calculating G. I'm going to do them both right here. Delta G prime equals negative RT natural log of K. And then delta G prime equals negative N Faraday's constant times the electric potential. Alright, so this electric potential is 0.67. Faraday's constant is 96,500. Number of electrons total is 2. So this is going to give me my delta G prime. I'm running off of this equation right here. This is the next one, that's not that one. So negative 2 times 96,500 times 0.67 equals, alright, a negative 12930,310. So this is in joules per reaction cycle for that reaction. Plug that number into there, and we'll get negative 129,310 equals, it's in joules, so it's going to be negative 8.31 times 298 times natural log of K. Alright, the K equals, alright, divide by negative 8.31, divide by 298, inverse, that's 52, inverse natural log the previous answer, and I get, alright, so my K value will equal 4.76 with 4 sig figs e to the 22nd. And that will answer the next question as well. Okay. Alright, flipping to the next page. There, that just answered that question. When the reaction comes to equilibrium, what would the value of delta G? It'll be 0. When the reaction comes to equilibrium, what would be the value of K? It is 4.76 e to the 22nd. Again, Q will equal K. Alright, so now we have a problem here. We have gold 3 nitrate is electroplated with 1 amp, 10 minutes. And so my question is, what's the half reaction? Okay, we're taking gold, Au, plus 3 electrons will equal Au solid. Okay, what's the mass of the gold being plated? Again, your options is just try these before you get to it. Alright, but here we go. Current equals charge times time. So current times time equals charge. Current is 1, 10 minutes is 600 seconds. 600 coulombs. Alright, 600 coulombs. Get rid of coulombs and go to moles of electrons. 1 mole electron is 96,500 coulombs. 600 divided by 96,500 equals 0.00621. Right, moles of electrons, and then for every 3 electrons we get 1 gold, and for every 1 mole of gold we get 196 grams, 196.97 grams. Alright, so we'll take our moles, divide by 3, times 196.97 equals, and we get about 0.4 grams. That's what I got. And it's 0.408 for 3 sig figs grams. And I believe that would be the whole thing. Thank you very much.